Hello ladies, gents, and everyone. It is Thursday, January 6th, 2022. I hope you are all having a good new year. I definitely really missed you over the holiday season, but we are here today to talk about this week's space and astronomy news. So the Mars helicopter was my choice for the best space and astronomy news story of 2021 thanks to its historic flight back in April. So what's Ingenuity up to these days? Back in December, the helicopter took its 17th flight and crossed the milestone of the total of 30 minutes aloft. Now, during this flight, Perseverance actually lost contact with Ingenuity, and it took 5 days for the JPL team to actually be able to confirm that this was a successful flight. It turned out to be due to a line of sight issue. There was basically a hill in between the helicopter and the rover. Now, this sort of line of sight communication issues could become more common as Ingenuity continues to try and push the limits of its radio range. The most recent flight of the helicopter was Flight 18, and it took it to a new airfield on Mars, its 10th airfield. Completing one flight was a technological marvel. Completing the entire mission was just amazing, and at this point, the little helicopter is operating well beyond anyone's expectations. It's really the little helicopter that could. It's amazing to see. There's no word yet on when the next flight will be, but I'm sure there is one planned. At last month's American Geophysical Union meeting, the principal investigator of the Juno mission presented an audio track from the spacecraft's flyby of the moon Ganymede back in June. Wait, an audio track? How is the spacecraft recording sound? Well, it's not. This data isn't from a microphone and it's not actually sound waves. It's from the WAVES instrument, which detects radio emissions from electric and magnetic waves in the magnetosphere of Jupiter. Now, these radio wave emissions are light, not sound, but they do have a frequency, and so to produce this soundtrack, they just shifted that frequency into the audible range and created a sound from it. This is a really cool way to experience the data, and it's really cool data. This is the first close flyby of Ganymede since the Galileo mission back in 2000. And I said the WAVES instrument is measuring Jupiter's magnetosphere, but in this case, it actually got close enough to measure Ganymede's magnetosphere. Now, Ganymede is the only moon in the entire solar system that actually has its own magnetosphere. And you can see in the data there are abrupt changes in frequency as the spacecraft moves into different regions of Ganymede's magnetosphere. So what a neat way to present this and really bring to life the experience of the Juno spacecraft and all the amazing science it's doing out by Jupiter. NASA announced on New Year's Eve that operations of the International Space Station will be extended through 2030. The commitment was made by the Biden-Harris administration, and they're seeking to work with all of the international partners as well. Now, Congress still has to approve the funding for this. They've currently only approved through 2024, but that is not expected to be an issue. The ISS has been continuously occupied for over 20 years and is operating well beyond its planned lifetime. NASA's post-ISS plan for low Earth orbit operations is commercial space stations, as we've seen last month with the awards to Northrop Grumman, Blue Origin, and NanoRacks for their commercial space stations. However, it's unlikely that any of these stations will be operational anytime soon, and in fact, last month the NASA Inspector General had raised concerns that this timeline was unrealistic. So it's not a surprise that the trusty old ISS is getting extended yet again. Here's to many more successful years. Most things in astronomy happen on timescales that are mind-bogglingly long for humans. And this is a real challenge for astronomers as well, because we can't observe a process from start to finish. We have to piece together what's happening from observations and theory. Stars, for example, take millions of years to form in the hearts of cold gas and dust clouds. Or do they? A new study published yesterday in Nature is claiming that stars might actually form 10 times faster than previously thought. Now, the basic idea behind star formation is that gravity is basically pulling together gas and dust, and that as it gets closer together and denser, gravity gets stronger, and so it pulls it together until you kind of run away into this collapse into a prestellar embryo and then a protostar. A hot, dense object that's very different from the cold nebula in which it formed. Gravity isn't entirely unopposed during this process, though. There are magnetic fields in the nebulae that actually resist this pulling together from gravity. But these magnetic fields in the nebulae are so weak that they're very difficult to study. Previously, scientists had managed to measure the weak magnetic fields of the overall nebula, or the outer layers of a prestellar embryo, and the strong magnetic field in the dense core of the embryo. But it took the world's largest radio telescope, China's FAST, or 500-meter spherical aperture radio telescope, to measure the magnetic fields in these intermediate layers between the core and the nebula. Astronomers were expecting the magnetic fields here to be relatively strong and helping to resist that gravitational collapse. But it turns out that they're actually very weak, just as weak as in the outer layers. The implications of this are that the magnetic fields aren't resisting the gravitational collapse as much as they thought, which means stars form a lot faster, maybe even 10 times as fast. Damn! Last but definitely not least, let's get you caught up with what's happening with the James Webb Space Telescope. Webb launched on Christmas morning at 7:20 a.m. Eastern. That was 6:20 for me, so that was a very early morning, but I'm so glad I got up to watch it because it was amazing! The launch went basically perfectly. In fact, the launch achieved the desired orbital parameters for Webb so well that the telescope used a lot less fuel than it was allotted, meaning there's now extra fuel on board. NASA has stated that this extra fuel will allow significantly more than the 10 years of planned lifetime, which is just awesome news. So Webb needs that fuel to maintain its orbit at the L2 point because it's an unstable orbit. But the launch was just the beginning. So Webb had to be folded up to fit inside of its launch vehicle. And so that means it has to deploy itself once it's in space. Now the first deployment was the solar array panel. And this actually happened early enough after launch, about 30 minutes after launch, that the spacecraft was still within view of the launch vehicle. So we got this absolutely epic footage of the solar array panel deploying. And this was basically the last time that we will ever see them. Now, the solar array and the first mid-course correction burn were the only two time-critical pieces of the deployment process, and they both happened on Christmas Day. Since then, the team has been working on deploying the telescope, and they're following a plan, but they're adjusting as needed. One of the most crucial and terrifying parts of this deployment process was deploying the sun shield, which keeps the telescope at a cool temperature required for its operations, as well as blocking light from the sun, earth, and moon. So this officially began on December 28th when the forward and aft unitized pallet structures were deployed. These structures contained the sun shield and all the various mechanisms needed for deployment, as well as providing support for the forward and aft ends of the diamond of the sun shield. Then on December 29th, the deployable tower assembly was deployed. This puts just a little bit more space between the telescope and the spacecraft to allow for more thermal isolation and room for the sun shield to deploy. And then on December 30th, the aft momentum flap was deployed. So this flap helps stabilize the spacecraft because the sun shield is like a solar sail. And so this flap helps offset the pressure of the solar photons that are pushing on the sun shield. So these were kind of the setup stages necessary to actually begin unfurling the sun shield. So on December 30th, the covers of the sun shield were released and rolled up. This was actually the first hiccup in the process. See, there are switches that are supposed to detect when the sun shield covers have been fully rolled up, and they didn't. So the team had to use additional data sources to determine if the covers were actually rolled up or not, including temperature data and gyroscopic sensors. Luckily, they were able to confirm that the covers were in fact out of the way, and so on December 31st, they began deploying the mid-booms, the port and starboard mid-booms. So these mid-booms, when they deploy, they basically unroll the sun shield, and they provide the support for the port and starboard points of the diamond. Now, because of the delay with the sun shield cover switches, this actually took a really long time and went very late into the night on New Year's Eve. So they decided not to begin tensioning on January 1st as planned, and instead let the team take the day to rest. Then on January 2nd, they actually decided to postpone the tensioning again, this time so that they could actually just take some time and study the data they were receiving from the telescope and how it was actually operating now that it was in space, particularly focusing on the power subsystem. And this also let a chance for the motors that control the tensioning to come to their optimal temperature. So the tensioning didn't begin until this past Monday, January 3rd. Now there are 5 layers to the sun shield that all need to be individually tensioned. So they got through the first 3 layers on Monday, and then they did the second 2 layers on Tuesday, January 4th. So basically at noon on Tuesday, the 5th layer was tensioned and the sun shield was officially fully deployed. This was a huge, huge accomplishment, and honestly, I was really worried about it, so this is just really, really great news. But we aren't done yet. Yesterday, January 5th, the secondary mirror was deployed. This mirror will direct light gathered by the primary mirrors and send it into the instruments. Without a secondary mirror, you don't really have a telescope, so this was a very critical step. But it went fine. Now, just this morning, the aft deployable instrument radiator was deployed. So this basically takes heat from the instruments and dumps it out into space away from the telescope. Whew. So that brings you up to date. Now the remaining major deployments are the wings of the primary mirror. So this had to be folded up for launch. The central section of the primary mirror is fixed, but the wings need to be basically deployed. The first wing deployment is scheduled for tomorrow, January 7th, and the second wing deployment is scheduled for Saturday, January 8th. And once these are completed, the telescope will be deployed. So keep those fingers crossed for just a little bit longer, but honestly everything has gone so well to this point. It is just such great news. It's very, 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 very amazing. Now, of course, the telescope still has to get to the L2 point, and then it has to get ready to take images and get first light and everything. So we won't be expecting to see any images from the telescope until June, but it's working so far. Alright, my Galactites, that's all I have for you this week. I hope you have a good one, and I look forward to seeing you again next week. Bye!